Hello everyone, welcome to Maan IS Academy, Chandigarh IS Academy. As I have been covering science and technology topics for the exam, I will continue to discuss about space science and technology. So today in space technology, where you can get question in the examination, I am going to discuss about a very important thing in terms of astronomical studies, like astronomy. In this context, I have covered earlier, Chandrayaan mission, Mangalyaan mission, Aditya L1 mission and all. But today, if you look at from ISRO, Indian Space Research Organization point of view, so I am going to discuss here a very important space mission. Right, we have AstroSat. We have launched this satellite 2015, but this satellite paved the way for another mission, what is called ExpoSat. So if you look at from astronomical research, astronomy, right, missions for country and whatever the important information we have to know from universe point of view. So there we have a two important satellite system. One is India's first astronomical satellite, AstroSat, which was launched in 2015, and then follow-up mission for X-ray polarimeter satellite, ExpoSat. This in the 2024 we have done that. So this is the first one. Now this is the second one. So now further, if you have to understand about AstroSat, now ISRO has decided to have a follow-on mission further on the AstroSat second. So what is first thing here? As I said, it is India's first astronomical satellite. Now this satellite carries instrument as payload together with a telescope, which can collect data from the universe, deep universe, to get understanding about various events of the universe. Satellite of India, right, it was launched in 2015. India joined the League of Nations like European Space Agency, European countries, then NASA, as you know, that American Space Agency, China, Japan. We have gone into those kind of club of countries to have such kind of a satellite mission. So we used the Polar Satellite Launch Vehicle to this one. Now here is a 1,515 kilogram satellite, right, which was inserted by PSLV rocket, inserted into 650 kilometers orbit. Now this orbit is not polar orbit, rather it is in place along the inclination of the equatorial part of it. This is the Earth. Right here, the satellite AstroSat, that is on this plane to the equator. There we have placed this particular satellite AstroSat. Low Earth orbit. What is something called low Earth orbit? Now it is a jointly here the instruments, and one of the very important instruments you will write in the exam, that is a ultraviolet, right, imaging telescope, UVIT. Instruments developed by TIFR, Tata Institute of Fundamental Research, which is a very important scientific research, right, organization in India, and ISRO, Indian Space. So you can say it is a joint mission of DAE, Department of Atomic Energy. That's where TIFR comes, and DOS, Department of Space, where ISRO comes. So here in this context here, so 5 payloads are there. There are total 5. this one 5 payloads. That means 5 instruments on board this satellite for studying universe. Right? Now, what is very, very important? Whenever you write answer, you should always make sure you are knowing about the objectives of the mission there. So, I'll now come to the objectives. What all findings, studies have been obtained from this AstroSat mission there? So, let me add here two very important things. First, it collected data, right, in 3 wavelengths. One is visible light, normal light, coming from the galaxies, stars, and such kind of events in the universe. Second is that ultraviolet, UV, ultraviolet radiations coming from space, and third, X-ray coming from such galactic sources where the image data can be used. You can say it's a multi-wavelength observatory. It's a multi-wavelength observatory. It has also been called by media as a Hubble of India. Just like NASA has got Hubble Space Telescope. So it is our Hubble. It is our Hubble, or you can say mini Hubble, right? Astronomical telescope of NASA, right? Similar to that, AstroSat is working. So what is here very important here is a first thing there, since it is a multi-wavelength, visible spectrum, ultraviolet radiation, and X-ray. X-rays, right, based observatory. It's a kind of a observatory to study, right, various aspects of the universe. Cosmological study. That's where it comes there. So let's say when you get question about astronomical research by India, so there you can mention this AstroSat mission there. Now second here, study of binary, there are 2 binary system consisting of a neutron star. When the star dies, here what something called Chandrasekhar limit, neutron star, and what is called black hole. When it is very, very massive, that star dies as a black hole, super dense matter, super massive thing there, which can absorb everything in the vicinity, in the neighborhood. Even the light can be absorbed. That's why it is name given black hole. And there might be, neutron star, there might be a black hole, right? It cannot be seen with normal light. And there may be another star which is made of neutron particles, electron, proton, neutrons, neutron star. And because of the gravitational force, they might be, moving around, right? It might be moving around itself. What is something called binary star system, where a star has died, one as a black hole and second has ended as neutron star, and they rotate, revolve, spin, right, their own center of gravity. That's what called here binary star system. And our AstroSat has found many such candidates in the universe, right? And this concept of black hole, neutron star, dwarf star, Nobel Prize awarded scientist from India, right? Dr. No, Chandrasekhar, who has given Chandrasekhar limit. If any star whose mass is greater than 1.44 times the mass of the sun will not become a white dwarf, but end up with other stages of their life cycle. Maybe red giant, supergiant, or supernova, where the star burst and then end with neutron star, or can end up as black hole depending on the mass, whether it's 5 times more than the mass of the sun or 7 times. It all depends on that. So second is the study of this binary star system. Now what comes here third? Right, to study of here, very, very important thing, high energy events in the universe. Let's say, such as, we can say here, let's say, very good example, supernova. When the star dies or star bursts as a supernova explosion. So the brief light, right, detect brief, or you can say very transient, temporary sources of energy. Sometimes, that may be pulsar, quasar, pulsating stars from stars and galaxies. Now again, survey, right, the sky, deep universe, just like what NASA's Hubble Space Telescope did that. Deep universe in X-ray, right, to study, right, events such as, pulsating star, pulsar, quasar, etc. Even survey the sky, normal survey of the sky, right, to detect sources of radiations which is coming to the Earth's atmosphere. From celestial objects. Since this mission was designed for a lifetime of 5 years, but we extended the mission. 2015 to 2020 was there, but we extended the mission here. So that's what it has been given the name Hubble of India, right? Now what I'm coming here, our next thing here, X-ray polarimeter, XPOSAT, right? I'll now come to our next very important mission, X-ray polarimeter, XPOSAT. X-ray polarimeter. Again, a satellite system launched by PSLV. Now, what is very important here? You can say it is a follow-on mission to AstroSat. Again here, study of universe. Particularly here, it is focused on black holes, because black holes emit some kind of radiations. Although it cannot, light will not pass through, light will be absorbed through that. But other kind of radiations coming from black holes and maybe X-rays, that can give us the idea here. Black holes, pulsars, quasars, etc. there. Now here, two instruments as payload. So it is a completely X-ray based. But there, whereas astrosat is a X-ray, UV rays, visible light. So one is called here, there's this very, very important here, X-ray polarimeter. That's a polarimeter kind of instrument, which is, I mentioned NISAR L-band, S-band, but similar to that, polarimeter instrument here, which works on X-ray radiation. There in NISAR you have L-band, S-band, that is radio wave, microwaves. But here we are talking X-ray. But the instrument is the same, polarimeters. Polarization of X-ray. Based on that, to understand black hole and all those events, even other star events and galaxies can be there, right? That was there. So one of the things was X-spect, X-ray spectrometer, right? So that kind of thing which to collect data. About the universe. So we have launched this one, right, previous year, 2024, with the help of PSLV, right? Launched by Polar Satellite Launch Vehicle into low Earth orbit, right? So this has been a very important landmark mission, which is a part of there. And in 2024, we launched that in the orbit there. And we used the Polar Satellite Launch Vehicle as a space rocket to launch it there. So again, various aspects. So India today not only study of moon or Mars or sun, like Aditya L1 mission, Mangalyaan for Mars, then Chandrayaan missions for Earth's moon. We have AstroSat for astronomical study and ExpoSat for X-ray polarimeter, that again astronomical studies. So India has now moving straight forward with such kind of space programs. And in future, we are going for Shukrayaan, study of Venus. Again, Mangalyaan will be second mission will be carried out. Plus we have again AstroSat. Next AstroSat we have planned for it. India is going to build Bharti Antariksh Station by 2035-36. So a lot of things are happening in the space sector from India. So there can be direct question in the exam to write. So when you're writing, then write with all the points, everything there. So I will be now going to other kind of areas of technology. So remain connected with us. Any kind of query or doubt you have, you can always get back to us, and we are always happy to help you out. Thank you. Stay connected. Thanks a lot.